Hello, it's part 2 of the Leak Stereo 20 project. If you've watched part 1, you'll see that I replaced all the resistors and all the capacitors underneath, and I put new valves in it. And because the mains transformer was burnt out, I was running it on an inverter with the output of the inverter, the 12 volt inverter, rectified, and using that for the HT, and also using the 12 volts for the valves. So I modified the wiring so that the EL84s were in series heaters on each side, and the ECC83s were had their heaters in series rather than parallel to run on 12 volt supply. But that inverter was a disaster. If you've watched the last video, very unreliable and not enough HT. So I have now at last got a new mains transformer for it, which you can see there, and took quite a while to come. But I realised why when I got it, because it had come from Lithuania, so just over a week to come. But I have just fitted it in there. I haven't at the moment wired it up, and I've had to drill some holes obviously for the various windings. You've got some massive thick heater windings there, and then we've got some blue HT windings, and the mains wiring. It's got two 115 volt primaries, and I presume that's an earth, which might be a screen between the primary and secondary connected onto that. But having tested this transformer at 230 volts on the primary, the HT winding with no load on it comes out at around 270 volts, which is a little bit on the high side, I think. Obviously it will come down a bit with a load, but I may have to experiment with the dropper resistor between the two elements of the can capacitor. But now the next job really is to unmodify all my modifications and then wire in the transformer. Okay, here's what I've done so far. I've put a new main switch in it. I had something there before which looked a bit like a switch, but it was severely damaged, so that will switch to live and neutral, which will come in on the IEC socket. And over here I've got a new bridge rectifier for the HT. It's a bit over the top. It uses 1N5408. Should be okay for the PIV, but obviously they're rated at 3 amps, but it's all I had available, so that'll be fine hopefully. What else is there to say? That resistor is the heater, not the heater, the HT dropper resistor. That will have to come out, and I'll probably put, to start with, two 470s in parallel, giving about 235 ohms, and we'll see what the HT voltage comes up at, because as it is, I'm getting 270 off the HT winding, and if you work out the peak voltage, it comes to somewhere around 380 volts, which is a bit too high. But now, having disconnected all the wires that went to the valve heaters, I've now got to reinstall all the old wires that went right to the valve heaters. Fortunately I did draw a map of that, so it shouldn't be too hard to do that, as long as the old wiring doesn't break up. Trouble with this old single core wiring, it can break quite easily, but I'm going to get on and do the valve heaters now. This bloody thing is driving me to drink. It's the only way I can cope with this old wiring. It's so hard to use rotten old wiring from the 1950s, single core wire, to get the valve heaters all wired up again as they were. Really the whole wiring loom needs ripping out and starting again, but that's not going to happen. But so the result is not very tidy, but if it works, that's the main thing. Right, here's the final solution of the wiring. So we've got the mains coming in there, go into the fuse and the switch, and I've sleeved all the mains connections, although that does seem rather pointless when you've got the best part of 300 volts plus DC floating around at various points. It would be easy to touch something, anything in this thing and get killed, shocks, whatever, but it's good practice to sleeve mains anyway. And then what have we got? We've got bridge, rectifier down there. Wasn't the ideal excuse me, wasn't the ideal position for it, but I didn't want to drill any more holes for the tag strip, so I just used a convenient screw that goes onto the capacitor mounting, but I think it should be okay. It doesn't look like it's going to touch anything it shouldn't. And we've also got an earth point in the middle, which goes to mains earth, and also goes to this thick wire which is the center tap for the valve heaters. In other words, 3.150, 3.15, that's how the valve heater windings are configured. And over there we've got two white wires, which are the 6.3 between those two AC. And what else we got? We got a bit of dual primaries on the mains input, so that's joining the two primaries in series at that point. And at the moment I've just got two 470s, which is coming in off the HT from the rectifier, bridge rectifier. Goes, then you've got a capacitor on either side of that, which is that. In other words, the two 470s are across there, or the resistive droppers across there. And I will probably have to fiddle around with those values, because at the moment that's roughly 335 ohms. But really the next stage is to test this bloody thing. Wind it up very carefully on the variac, see what it does. But before I do all that, I'm going to clear my bench off, because it's a right bloody mess, covered in bits of wire and junk and all sorts. Okay, this is a test setup. I've got my variac over here and set to 0 volts at the moment. No valves installed, so I'm just doing a DC HT test and valve heater test. So this one will be me reading the HT, which at the moment says 3.2 volts, and that one is the AC on the valve heaters. So I'm going to turn the variac up. It goes 10 volts, 20. Yep, I seem to be getting some increases. I'm getting 50 volts on the HT. Bit higher, bit higher. That's 100 volts AC input, 167 HT, and 3 volts on the valve heaters. So go a bit higher. That's 150 volt AC input, 250 out on the HT. Right, might as well take it all the way up. That's 200, and that is 230. So I'm now getting 365 volts HT, fairly high, and 6.7 AC on the heaters, which of course will drop when you get a bit of load from the heaters, which is fine, of the valves. And of course there's no load at all on the HT at the moment, so that's why it's way up at 365. And on that point I'm measuring on, it should be, I think, about 325 when it's working properly. So I really think the next thing is to try some valves in it. Then we'll see what we get on the HT, which is what I'm more concerned about than anything. Obviously nothing's blown up, because it's always a bit of a risk. Because of the way this thing's configured, I've now got 365 volts on the centre tap of the output transformers, speaker output transformers, and if they had some leakage to earth then they could conduct, but they're not, as far as I know. But anyway, it seems fairly safe at the moment, so I'll get the valves put in it and then we'll see what it does. Okay, valves are in, and I'm now going to monitor HT at that point after the dropper resistor. So it says on here should be 310. I think it'll be a fair bit more than that, but anyway, all connected up, and I'm just going to monitor HT, which I'll get in on the meter and gradually turn the voltage up again. Oh dear, I forgot to plug the bloody thing in. Right, plugged in now. Going up, going up. What's that say? 55 volts, okay. And we've got about 100 volts AC going in. Oh, there's always a nervous point, this is. Waiting for something to explode. Well, that's a bit high, isn't it? 280 volts. No, it's not. It's okay. I'm getting mixed up. Okay, it's coming up to 230 now. And obviously the valves are starting to conduct and they're pulling the supply down, the HT down, to 303 volts. 302 volts. And it says it should be 310. So that's with two 470s in parallel instead of the 100 it had in there before. And that might be a wise place to leave it. One would assume it would draw more current when it's driving into a load. So probably the best test now would be to drive it into a load with some signal. Yeah, and keep monitoring that HT point, which I've got to be very careful about because I want to turn the amplifier over, and I've just got a crocodile clip connected onto the HT, so I might solder a wire onto there. It'd be safer than the crocodile clip. So there you go. Okay, to cut a long story short, always got guitar, sorry. I put another 470 ohm across the two that were in there because the voltage was dropping a bit with a load on the output. So I've got approximately 156 ohms in that resistor, and I'm getting 307 volts when it's driven to its full output, and it seems to be working fine, but I'm sure it'll blow up at some point. They usually do, don't they, things like this. Well, let's have a look at this scope, and it takes next to nothing to drive this amplifier. It's far too sensitive. I've only got 28 millivolts going at the moment, so what I want to do now is crank it up to clipping, and I've got my HP audio analyzer connected across the 8 ohm, one of the 8 ohm loads. I'm reading power on the HP at the moment, so let's just crank it up a bit till it gets to clipping. That's sort of a bit clipping, a lot clipping. Let's see if I can get that a bit better. Right, that's maximum. And up here we're reading 12.8 watts, which I think is fairly reasonable, because I was under, I'll turn it off a minute, I was under the misapprehension that because this thing was called a Leek Stereo 20, it was 20 watts per channel, but it's no such thing, it's just 10 watts per channel. So I was getting 12.5 watts, so I think that's a fair amount of output for this amplifier. I think it'll be fine anyway. So now I just do a little distortion test at 1 kilohertz, because we've already got it set to clipping, just below clipping, and that's still on watts at the moment. So I go back to AC level and distortion. So I'm getting 1.3% distortion, which seems fair. It seems that valve amplifiers do have a bit of distortion, so I can turn that output down. Right, turning that down makes a considerable difference. It's now 0.3%. I think that's pretty good, because I'm sure it's still producing a fair few watts. So if I go back into AC level, 19.0 special function, you see that's 9 watts still, and it was down to 0.3%. 0.3% distortion. Yeah, I think that's pretty bloody impressive. So let me just do a frequency response test. Maybe turn it down a little bit, because I am hammering it. So what we got now, 19.0 special. So that's 4.5 watts. Let's do a frequency response test at 4.5 watts. Now this is, I'm on 1 kilohertz, see, 1 kilohertz there, that's the AC level at the moment. So I now have to put it into ratio mode and logarithmic. So that's the base level, that's your reference, 0 dB at 1 kilohertz. So now I'm going to change my frequency. I'll go right down to 20 hertz, which is a tough thing for a valve amp, tough frequency. And it's 0.2 dBs down. I think that's pretty impressive for effectively a transformer output. So let's go up a bit. That's 100 hertz. 0.1 dB down at 100 hertz. 200. 3. Nearly almost flat now. 6, 7, 8, 9. Back to 1 kilohertz. 2 kilohertz, 3, 4, 5, 6, 7, 8, 9, 10 kilohertz. Oh, it's trying to drop off at 10 kilohertz, 0.25, 11, 12, 15, 14, 15, half a dB down at 15, not bad, 16, 17, 18, 19 and 20 kilohertz, 0.7 dB down. Not bad at all, I think. Probably take it a bit higher. That's 25 kilohertz a dB down. That's good enough for me. So I think that completes the testing of this thing. Can't think of any more tests to do on it really. So I can do one more demonstration. I will disconnect all this rubbish on the bench, take it in the lounge, wire it up to my nice big Celestion Ditton speakers, and the guy I'm doing this for has given me a CD which he says is copyright free. Well, I hope it bloody well is, It's a local band which I've been at various places when they've played in the past. So it's better than the YouTube library, which I was going to use anyway, so I'll just take it all in the lounge and set it all up. Okay, we're in the lounge, it's on the floor as you can see, and the cat is on the window, so I'm going to upset him in a minute with the noise. Hums a bit, I don't know if you can hear it. I've got some sort of weird earth loop going, I think, because it's completely silent when you unplug the phono plugs. But I'm not bothered about earth loops at the moment. So the setup is CD player, which goes into this amplifier, which has been modified to have a preamp output, because I like to be able to adjust the bass and treble a bit. And that normally feeds my homemade MOSFET amplifier, but it's coming out on this, and I've got a 10:1 attenuator on it, made up on the back of there, because the amplifier, the valve amp, is just so sensitive. So let's start up the CD. And it may not be to your taste, but it's better than YouTube music. Oh yeah, Celestion Ditton 44 speakers. Very sensitive speakers.
We love each other, we love the sun, arms around the shoulder, no need of a gun. We got no need of a gun, we got no need of a gun. We got arms around the shoulder, no need of a gun. We love another, we love the moon, arms around each other. Peace is coming soon, spreading all over, going all around, moving through the country, the city and the town, spreading all over, going all around, moving through the country, the city and the town.
Okay, that's enough I think. Sounds pretty good to me. And 12 watts, I probably didn't go anywhere near 12 watts output because these speakers are so sensitive. And I've upset the cat, he's woken up. Poor cat. But that's enough of disturbing him for today. Yeah, people get the wrong idea about power. If you've got really sensitive speakers, 10 watt amplifier is more than enough, or 12 watts in this case. So I think that concludes the video, so I hope you enjoyed it, got something out of it. Give me a thumbs up and whatever. Bye for now.